All right, welcome back. This is lesson 2 on normal distribution. And we're just going to recap real quickly over what we talked about yesterday. So we're on page, then we're going to dive into the new portion. Page 776, number 10. So we're still going to be looking at number 10, but I'm going to add some extra questions to this. And you guys are going to see the difference between what we did yesterday, where our values lied right on lines of standard deviation, and today where they don't. Okay, so first let's draw the curve. Try to get it symmetrical. I'm not an artist, but if I work at it here. Just have to work harder at the second side. Okay. And how many lines of standard deviation to the right? Well, we have 3. Okay, so 3 lines of standard deviation to the right, 3 lines of standard deviation to the left. Now I'm going to say this. If you're watching this video before watching the last video, I recommend, if you're struggling normal, to make sure you watch video 1 first, okay, because that's going to make the difference. This is the second lesson on normal, okay. You must see the first one before you see the second one. Okay, so if you missed class, make sure you watch the first video first. This is z equals 0. We talked about this. Z equals 1. Z equals 2. Z equals 3. Z equals -1, Z equals -2, and Z equals -3, reminding you that z-score is a 2-part definition. It is the number of standard deviations to the left or right of the mean, also the formula. Okay, the formula today that we're going to use is Z equals x minus mu over sigma. So if you don't have those in your notes, make sure you go back to the last video and get that definition down. 2-part definition. The first part was number of standard deviations to the left or right of the mean. That's what z-score is, and then the formula. We're going to be using the formula today. Now, total area. Always write this. Total area of the curve. Total area is what? 1 square unit. Okay. Total number goes here if given. Okay. Total number if given. And our center line. Center line is the mean or the average. Now, within 1 standard deviation of the mean, reminding you, again, you have to remember these. Within 1, within 1. Within 1 is what? Within 1 is 68%. Within 2 is 95%. And within 3 is 99.7%. Okay, so within 1 standard deviation of the mean is 68%. Divided into 2 equal parts is 34%. 34%. Within 2 standard deviations of the mean is 95%. Remember, we talked about subtracting. You can figure this out by subtracting. We're talking about increase. What is the increase from 68 to 95? Subtract. Take 95, subtract 68. 95, subtract 68. Again, use a calculator. Definitely have a calculator for this lesson. I want you guys paying attention to the concepts, not the arithmetic. Okay, so take 95, subtract 68. So if you need to pause, go grab one, come back. Okay, 95, subtract 68 gives 27%. Divided into 2 parts is 13.5%. 13.5%. The more you do this, the more you're going to remember them. Within 3 is 99.7%. Almost 100. 99, guys. 99.7%. Divided. Okay, so take 99.7, the increase. Take 99.7, subtract 95 to get this increase on both sides. 99.7 subtract 95 gives 4.7%. Divided into 2 parts is 2.35%, and what? 2.35%. And we're looking at the small areas that we never forget. The micro areas are what? 0.15% and what? 0.15%. You can find these by taking 100%, subtracting 99.7, which gives 0.3% increase for both parts. Divide by 2, you get 0.15%, 0.15%. Extremely small. All right, now, let's get the information out of the problem. Number 10, reminding you, we're on page 776. Number 10, again, it says the useful life of a certain car battery is normally distributed. So when you hear the words normally distributed, what do you draw? You draw the bell curve. This shape, again, is a bell curve. The function is the normal distribution function. Okay? And so when you hear the words normally distributed, you draw the bell curve. And now we get the information out of the problem. So let's get the information. It says that the mean is 100,000. So our center line, we're not centered at 0, guys. The center line is what? Mu is, or the mean is 100,000. Okay, and our standard deviation, sigma, is equal to 10,000. Remember, we think of sigma as distance. Okay, the distance from the center to one standard deviation to the right is 10,000. Okay, so the distance is 10,000, remember? This distance is 10,000, so to go one standard deviation to the right to get to this line, we take the center of 100,000 and we add what? We add 10,000. Okay, so we're going to add the distance. 100,000 plus 10,000 gives 110,000. Remember, this value falls at the bottom of this line. Okay, add another distance, add another 10,000, we get 120,000. Remember, this falls at the bottom of this second standard deviation line. Add another 10,000, we get 130,000. To go to the right is to add, to go to the left is to subtract. So to go to the left, take 100,000, subtract 10,000, we get 90,000. Okay, again, to the left, 90,000, subtract 10,000 is 80,000. And then what? 70,000. Again, reminding you, 90,000 is on this line, 80,000 is on this line, 70,000. Okay, so quick recap. Guys, what is the z-score for x value? Remember, on the bottom are your x values. 70,000, 80,000, 90,000, 110, 120, 130. The x values change problem to problem. And the z-scores up top never change. Never change. And that's going to be the key today. All right, so what's the x value here? 120,000. So for x value 120,000, what is the z-score? The z-score is what? The z-score is 2. This means that 120,000 is 2 standard deviations to the right of the mean. Now, for x value 130,000, the z-score is 3, meaning that 130,000 is 3 standard deviations to the right of the mean. And for x value 80,000, the z-score is -2, meaning that we are 2 standard deviations to the left of the mean. Now, let's look at the problem. First problem on that homework, or first problem on that example, I should say, number 10. Just showing you a quick recap. 10A says how many batteries will last between 90 and 110,000 miles. Remember, we don't find just how many, we find percentage. What else? Percentage, probability. And probability is the same as area. That's going to be very important today. And how many? Now, to find percentage, we're looking at between what? It says between 90,000 and 110. So between 90, I'm circling, between 90 and 110. Okay? And we're looking at what area? We're looking at these two areas. Okay? Between 90 and 110. Add these two areas up, or add these two percentages. 34% plus 34% gives what? 68%. To convert percentage to probability, we move the decimal 2 places to the left, which gives a probability of 0.68. And to find how many, we take the probability of 0.68, multiply by total number. By the way, forgot to write this. Total number. Okay, in the problem it says the company makes 20,000 batteries a month. So there were 20,000 batteries produced. That is your total number of batteries produced for this batch. Okay, how many is found by taking what? Probability multiplied by total number of batteries produced. 0.68 times 20,000 gives 13,600 batteries produced. Now, the question today is here. I'm going to add, we have an A, B, C, and D for this question. Now I'm going to add, just like I'm going to do on your homework, a part E. Okay? And part E says P, probability. P stands for probability. Okay, and I'm asking the probability. Now, if I ask you for probability, am I asking you just to find probability or area? No. I'm asking you to find all three. Percentage, probability, and how many. Okay, so probability, just remember you're finding all three. But I'm just writing it as probability that X, we read this as X is smaller than 115,500, or let's do, what did I do? 115,271. Let's do it like that. 115,271 miles. Now, this is domain. We read this as X is smaller than 115,271. X is smaller than 115,271. And X is smaller than means to the left. Okay, to the left. Now, reminding you, what are your X values? What are your X values? Your X values are 78,000, 80,000, 90,000, 100, 110, 120, 130. My question is, where does 115,271 lie? Okay. Hopefully you guys say 115,271 X value would be between, here it is. Okay, so you're going to have to pay a little closer attention in this one. Between what? Between 100,000 and 120, somewhere right here. Okay. Now, before we get into this, we need to talk about, okay, well, let's go ahead and mark it. Where's 115,271? 115,271 is where? Again, it's between 110 and 120. So I want you to mark this location. Draw a vertical line right here. A dark vertical line, approximately where you guess. Just guess it. Where do you think 115,271 is? It's between 110 and 120. I want you to put a vertical line here, marking the border. And I want you to write at the bottom 115,271. Circle it. It becomes the most important value in the problem. And question, what type of value is this? 115,271 is what? An x value. Okay? It's an x value. Now, before we get into, all right, notice that the previous problem asked between, I'm just going to write probability that x was between, here. The probability, here, let me write it here. Probability that x was between 110 and 90, or 90 and 110. 90,000 and 110,000. Well, what do you notice about these two values? The values 90,000 and 110,000 are x values, but where do they lie? 90,000 and 110,000 lie where? They lie on lines of standard deviation, allowing us to just simply add the percentages. They lie beautifully on a line of standard deviation. So you add 34 and 34. But notice, 115,000 does not lie beautifully on a line of standard deviation. We're somewhere between. Okay, so this is where our z table is going to come in. Now, I've given you all a z table, every single one of you, and we're going to talk about how to read the z table. So I want to do this really quick. We're looking at, question, what is the total area of this curve? What is total area underneath this curve? Total area is what? 1. So the total area is 1. So if I look at partial area, if I look at this area inside of here, in this little region here, is this area bigger than 1 or smaller than 1? Well, hopefully you remember, 34% chance is a probability of what? A probability of 0.34. We say that probability is the same as area, so the area is 0.34. Do you see that this area 0.34 is smaller than 1? Absolutely. So we're talking about a partial area. Okay? The largest area that you can have is 1. Anything smaller than that is a partial area, which will be smaller than 1. Now, let's look at the z-table for a moment. Now, I don't have a paper copy. I just have one out of my old statistics book here. So don't worry about the complicated looking formula, but I want to put this up here for a minute. Okay, so we're looking here at the z-table. Okay? I want you to look in the center of the table here. These values. Okay? These values in the center of the table. I don't want to talk so loud. I'm right by the camera. Okay, these values in the center of the table, all of these numbers that you see, 0.85, 0.87, 0.89, are these values bigger than 1 or are these values smaller than 1? Okay, hopefully you see these values are what? All these values are smaller than 1. Every single one of them. What is this talking about? These values inside the table that I just showed you are areas. They are partial areas. So what does the z-table give you? Or I'm going to say, what does the z-table give you? What does the z-table give you? I don't know why it always sounds wrong to say. What does the z-table give you? The z-table gives you, the z-table gives you, oh, horrible. All right, what the z-table gives you area, okay? It gives you area. And the areas are going to be partial areas that are smaller than 1. Now, let's look again. Something else about the z-table here. Okay, I want you to notice at the top. Notice all my papers. I got papers in here. These are all old homework assignments. I stuff them in my book. All right, so up top, notice this area that's shaded. The area is where? The area is to the left. What portion of area is shaded? The portion of area that's shaded is to the left. Okay, so the z-table gives us area to the left. Okay, z-table gives us area where? Area to the left. Now, I want to look back at the problem here for a moment. Z-table gives us area to the left. Let's look at what this problem is asking for. The problem says we want to find the probability. Again, we're finding what? We're finding all three. Percentage probability. Let's go ahead and write that. We're going to find percentage. What else? Probability. What is probability? Probability is area. And how many? Okay. All right, so we're going to find percentage probability, how many for this region. What does this say? the probability that x, these are our x values down here, that x is smaller than or less than 115,271. So are we to the right, smaller than, less than? Is that to the right or to the left? Hopefully you say that's where? That's to the left. Okay, so I'm going to erase some of this. And let's just kind of partially highlight some of this area. I don't want to have to redraw this curve, so I'm going to draw it lightly. Do you guys agree that we're talking about all of this area where? All of this area to the left. So I'm highlighting all of this, all of these regions to the left. Now before we start, and we actually use our z-table, I want to guess what this area or what this percentage of area is. So we're going to guess. I want you in your percentage portion here, I want you to write next to your percentage a guess. Okay, and put question mark, guess. You always want to guess and be close before you ever estimate, before you ever use your z-table. So let's estimate our area. Now question, what percentage, notice this is the mean is the center. What percentage is to the left of the mean? What percentage of area is to the left of the mean? Well, hopefully you say that's half of the curve. That's 50%. So then we got 50% of the area down here. Now, we have 50% plus what? We have 50% to the left of the mean plus what? Another 34%. What is 50% plus 34%? Again, you should have a calculator, 84%. So we agree that this portion to the left of 1 standard deviation, or z equals 1, to the left of z equals 1, is a 50% plus another 34% gives a total of 84% of the area. 84% of the area. So my question is, the area that we're trying to find, the area that's to the left of 115,271, is that bigger than 84% or less than 84%? Hopefully you say bigger. It's bigger than 84%. How much bigger? Well, let's look. Okay, so we're somewhere, 115, is it somewhere between halfway, between 110 and 120? Well, yeah, it's a little more than halfway. So we're a little more than halfway in this other area here. And this other area is 13.5%. Now, my question is, we're a little more than halfway, but where is most of the area? Notice that the curve is falling. If I draw this here, let me do an exaggerated version. If I draw the normal distribution, here, exaggerated version, the normal distribution comes down and drops very suddenly. Okay, if I draw a line of standard deviation here and here, my question is, if I put a line right here, my question is, where do we have more area? Okay, or I should say, do we have half, is this cutting the area in half? No, this is not cutting the area in half. Notice, do you guys see that to the left of halfway is a lot more area than to the right? Okay, so we definitely have more than half. Okay, so we're going to say that this area here is more than half of 13. Let's more than half of 13. Okay, half of 13 is 6.75. Okay, so more than 6.75. How about we say 8 or 9%? More than 8 or 9%. So let's add. So we've got, look, we've got 50% plus another 34% gives 84%. And now let's add a little more. So how about we add another 9%? Okay, another 9%. So 84% plus another 9% gives what? A total of 93%. So we're looking at our guess to be somewhere around 93%. 93% of the total area underneath this curve, which is almost all of it, okay? Now, so we're guessing our percentage to be somewhere around 93 before we start. Why do I say this? It's very important to keep in mind what your percentage is, because you can eliminate answer options, especially if you're looking at a multiple choice question. I see students choose the answer 10%. Okay, guys, is this 10% to the left? No, it's more than 50%, guys. It's far more than 50%. So you can at least estimate it's somewhere around 93. And in fact, many questions can be answered without doing anything. You just see 93%. Well, all your answers are 10%, 15%, 20%, then you have like a 94%. Which one's the answer? Well, it's going to be the one that's close to 93. So we're somewhere around 93%. That's an important guess before we even start the problem. Now, I want to say this again, reminding you, what does the z-table give us? What does the I always have a hard time saying. What does the z-table give us? Okay, notice again, looking here. Okay, in the table, again, the z-table gives us what? Area. Notice these values are what? Less than 1. They are partial areas. Again, it gives us also area where? Area to the left. Do you guys see this shaded region? Is that all of the area? No, that's part of the area. Now down here, do you notice that these values are smaller than 1? Okay, that's part of the area. Again, the total area is 1. The z-table is giving us partial areas. Now, I'll show you how to use the table in a moment. Okay, so we're looking at, to calculate this percentage, or this probability, notice, what will the z-table give us? Circle this. Z-table is going to give us probability or area. Okay, we're going to be looking up on the z-table the probability or the area. Now, notice, 115,271 does not lie perfectly on the line of standard deviation. So we have to calculate its z-score. I want you guys to also guess. What do you think the z-score is going to be? Okay, notice, this is z equals 0, z equals 1, z equals 2, z equals 3. Where is this line? This line is between what? 1 and 2. I encourage you guys to take good notes on this lesson. It does not have to be on graph paper. It's between what? 1 and 2. So just guess it. Guess it. Somewhere between 1 and 2. Many students will say, well, it's going to be somewhere around 1.5. That's correct. Okay, somewhere around 1.5. The z-score is going to be between 1 and 2. So we should also have an idea of what our z-score should be. Now, in order to convert 115,271 to z-score, okay, so there's 3 steps. Let me say it. 3 steps. First, you have to shade your area. What area are you finding? You're finding area where? To the left. So you're finding your area. So shade your area. You draw your border, put your x value, shade your area. Okay, so shade your area. Now find z-score. So we're going to convert this to z-score, okay, because we can't know our area precisely unless we look it up on that z-table. Okay, so we're going to convert the x value to z-score, and then thirdly, we're going to look the area up. Okay, so 3 steps: shade the area, find the z-score, then look it up. Okay, so we're going to find our z-score now. We shaded our area. Our x value is 115,271. So I want you guys to calculate the z-score, and we're going to use that formula that we memorized. The formula for z-score is what? Z equals x minus mu over sigma. Okay, now there are 3 values. To find your z-score, there are 3 values in this formula. There is mu, there's sigma, and there's x. Now you already know what mu is, or the mean, or the average. The mean is what? 100,000. We already know our standard deviation, or sigma. Okay, that's 10,000. Now my question is, what is the x value? What is the x value? Well, it's the x value that you're trying to convert. It's what we circled. 115,271 is the most important value in this problem. Why? The border. The border of the shaded region is the x value that we're trying to convert. Remember, 115,271 is the x value. We want to get its z-score. We're guessing the z-score to be somewhere around 1.5. This formula will convert the x value to z-score. So now we're going to convert. So our x value is what? 115,271. 115,271. Subtract the mean. What is our mean? Our mean is 100,000. So subtract 100,000 divided by 10,000. I tell students this: be careful. Subtract first and get your value. So subtract the top 2 first. What do we get? 115,271 subtract 100,000 is 15,271 divided by 10,000. Now divide. Now divide. 115,271 divided by 10,000 gives 1.5271. Now, z-scores go to 2 decimal places. So I want you guys to draw a line. We always round z-scores to 2 decimal places. So draw a line here between the 2 and the 7. Now my question is this going to round up or is this going to round down? Look at your 7. 7 rounds up or down? Well, hopefully you say 7 rounds up. So we're going to have a z-score of 1.53. So go ahead and write z equals what? 1.53. Okay, and let's write that over here. The z-score equals 1.53, and circle that as well. Okay. Does that make sense? Yes. We said that our z-score should be somewhere between 1 and 2. Does 1.53 make sense? Yes. And what does 1.53 mean? 1.53 means 1.5 or 1.53 standard deviations where? To the right of the mean. Okay, so our z-score is 1.53. Now all we have to do is look it up. Okay, so I'm going to show you to look this up on the z-table. There is a column on your z-table, okay, on the far left. This is the z column, okay, and I want you to go down to 1.5. Okay, so you go down to 1.5, and then you go right to the 0.03 column. Okay, so 1.5 is the first decimal place. Right to the 0.03 column gives you your second decimal place because we're looking up 1.53. Go down to 1.5, right to the 0.03 column. It's 4 columns to the right. Let's get this value. I'm going to show you here on the camera. And then for the rest of this, I'm just going to assume that you know how to read your z table. So we're going to go down. We're going to go down to what? You notice this is our z. Oh, this is our z column. We're going to go down where? We're going to go down to 1.5. Okay, that's here. Looking back up, do you see your columns? You see 0.00, 0.01, 0.02, 0.03. So there's the 0.03 column going down. Okay. And our fingers here, so 0.03 column, we have what? 1.5 to the 0.03 column is 4 columns to the right, gives a value of 0.9370 right here, 0.9370. Okay, so we're getting 1.53 is 0.9370. Let's write that. 0.9370. Okay. Now, reminder, what does the z-table give us? Okay, the z-table gives us what? Area to the left. Okay, is that what we're trying to find? Yes. Remember the highlighted portion on the top of the z-table. I'm not going to put it up there again. If you need to rewind the video, the z-table gives us area to the left. Okay, our area, notice our total area is 1. Okay, and the area to the left is a partial area, so we're expecting our area to be what? We're expecting this area to be smaller than 1. Is 0.9370 smaller than 1? Yes. So what is our probability? Remember, z-table gives us the probability of the area. This is 0.9370. Okay, so that's what you get off of your z-table. That's your answer. Okay, now to convert this to percentage, we're going to move the decimal 2 places back. So move it 2 places to the right. We get a percentage of what? 93.70%. Okay, and now to find how many, we take our probability, which is 0.9370, and multiply by the total number. So take 0.9370, multiply by 20,000, you get, let's see, 186, 187, 187, 4. Let's see, 4. Yeah, greater than 1. 18,740, yeah. So 18,740 batteries, 0.9370 times 2 is 87.4, yeah. All right, so we get 18,740 batteries is the total number of batteries in this batch, okay? Now, let's see what we want to do here. Let's see. Okay, so next question. Let's look at this question. Let's look at F. Okay, actually I'm just going to erase this. Well, no, we can do this. E, F. We're going to look at the probability that X. Yeah, well, I'm going to have to redraw. Let's go ahead and move to question number. Let's move to the next question because I'm going to reshape this area. All right, so let's look at question number 11. Set this curve up again. Okay, question number 11. Just going to quickly draw this out. All right, question number 11 says what? It says on page 776, the cholesterol level for adult males of a specific racial group is normally distributed. When we hear the words normally distributed, what do we draw? We draw that bell curve, okay? And then try to be as symmetrical, try to draw this as symmetrical as you can. Okay? But again, I'm not judging you guys or grading you guys on art, okay? 3 lines of standard deviation to the right, 3 lines of standard deviation to the left. Okay, but try to do the best you can. And, see, I'm not even that good at it. All right. Z equals, we have what? Z equals 0. Z equals 1. I just say that so that you guys can read it. Okay, that's why I'm concerned about you guys being somewhat neat so that you can read what you put up here. Okay, I've seen students that have a hard time drawing this, and it's very hard for them to read it. Okay. -1, z equals -2, z equals -3. And we're looking at, again, our mean. Well, I'm sorry, let's get our percentages. Within 1 standard deviation, is what percentage? Within 1 standard deviation is 68%. Within 2 is what? 95%. Within 3 is 99.7, almost 100%. Okay, and now we're looking at 68 divided into two equal parts is what? 34% and 34%. Take 95, subtract 68, we get an increase of 27 divided into two parts is 13.5%. The more you do this, the more you're going to remember them, guys. 13.5%. Now take 99.7, subtract 95. 99.7 subtract 95 is what? An increase of 4.7 divided into two parts is 2.35% and 2.35%. And lastly, these micro areas that we never forget. Micro areas are what? 0.15%. 0.15%. Okay. And total area of this curve. Total area is what? Total area is 1 square unit. Okay, 1 square unit. And up here goes total number if given. Okay, again, this is problem number 11. Should change this. Look at number 11. All right, now let's get the information out of the problem. Now, if you look at part B, students say there's no total number given here. Yes, there is. If you look at part B, it gives you a total number. Okay, it says how many of the 900 men in the study. Okay, so how many men were surveyed in number 11? Okay, part B gives you the total number of what? 900 men were surveyed. Okay, and it says the cholesterol levels of a specific racial group is normally distributed with a mean of 158.3. So our mean is 158.3. And our standard deviation, sigma, equals 6.6. Okay, so our center is 158.3. And our distance to get to the next line of standard deviation is 6.6. So go to the right is add 6.6, add 6.6, add 6.6. So take 158.3, add 6.6, you get 164.9, add another 6.6, you get 171.5, add another 6.6, you get 178.1. Now subtract 6.6, so 158.3 subtract 6.6 is 151.7. Subtract another 6.6, you get 145.1. Subtract another 6.6, you get 138. 138.5. Now, the question I'm going to ask is to find. Okay, we're looking at. I'm just making up a problem here. It gives you a part A and a part B. I'm just creating a part C, okay, to find the probability. Now, again, if we're finding probability, what do we find? All three. We're always finding all three. Percentage, what else? Percentage, probability. Probability slash what? Area. And what else? How many? And just check the camera real quick, make sure we're all good. Okay, we're still good. Okay, percentage, probability, or how many, and we're looking at the probability, again, finding all three, that X is greater than, let's do 160. Probability that X is greater than 160. Now we read this again as greater than, okay, is to what? Greater than is to the right. Okay, so we're to the right, and we want to find where is 160 located. So we're interested. This is an X value, reminding you what are our X values. X values are on the bottom. Notice, did the X values change from the last problem to this problem? Yes. But what did not change? What did not change? The Z-scores did not change. The Z-scores remained constant. Okay, so we're looking at X value of what? X value of 160. So there's three steps. What are they? Shade the area, find the Z-score, then look it up. Okay, so shade the area, find the Z-score, look it up. We've got to shade the area first. So we have to find where is 160. Well, 160 is somewhere between 158 and 164. Okay, it's closer to 158. So let's draw a line here, somewhat closer to 158, vertical line. And mark at the bottom. What is the bottom value? The bottom value is what? 160. Circle that. That is your X value. Super important. Remember, X is greater than 160. So 160 is our X value. That goes in the bottom. We want to calculate what? We want to calculate a Z-score because 160 does not lie perfectly on a line of standard deviation. So we have to take 160, convert it to Z-score. But what I say, three steps. Shade the area, find the Z-score, look it up. So let's shade the area. Now, this is X is greater than 160. Is that to the left or to the right? Hopefully you say greater than means what? To the right. So I'm going to shade this area. Hopefully you guys agree that we're finding the area here. Okay. And let's estimate our area. So my question is, this area that I just shaded, is this greater than 50% or is this less than 50%? Is it greater or less than 50%? Hopefully you say that this is less than 50%. Now students look at this. Several guesses, okay, several guesses in class. And we came out to a guess of somewhere around 40%. I mean, if you think of this, this is a pretty large portion of area right here. Now, I'm not supposed to be shading this, but this white space here. This white space is a pretty large portion of area that's missing. Okay. Now, if this is 34%, this whole region here is 34%, I think we think maybe a third. Okay, and a third of 30 is about 10. So we take 50%, take out this 10%, we're somewhere, our guess, we want to guess this, we're guessing somewhere, G-U-E-S-S. We're guessing something, put a question mark. Okay, guessing something around what? 40%? Okay, guessing somewhere around 40%. Now, so we're to the right, and we're guessing this percentage to be somewhere around 40%. Okay, so we've shaded our area. Now we have to find our z-score. Okay, I always say guess it as well. Shade it and guess it. Okay, z-score. So to find the z-score, we have to convert 160 to z-score. We're going to use the formula. The formula is z equals what? X minus mu over sigma. Okay. Now again, reminding you, do we know the value of mu or the mean or the average? Yes, that is what? 158.3. Okay. Do we know sigma or the standard deviation? Yes, that is 6.6. What do we not, or what do we know x? Okay, this is the one students have a problem with. X. What is x? X is the x value that you circle, the 160, the value that you're trying to convert. Okay. So x is 160. We're going to subtract what? Subtract the mean, okay, which is 158.3, and divide that by what? 6.6. Now again, what is our z-score supposed to be between? Our z-score is supposed to be between what? 0 and 1. So when we get done, our z-score should fall between 0 and 1, because our line is between 1 and 0 and 1 standard deviation to the right. So let's subtract first. Remember, subtract first. What do we get? 160 minus 158.3 is 1.7. Okay, so we have 1.7 over 6.6. This is somewhere around 0.25. Let's see, 0.26. Let's see. 0.7 divided by 6.6 gives what? 0.257. So we get approximately 0.257. Now, I want you guys to remind you that we're putting a line. We always round our z-score to 2 decimal places. So put a line between your second decimal place and your third. Okay, question, is 7 rounding up or down? Hopefully you say 7 rounds what? Up. So we have a z-score of 0.26. Okay, we're going to round up to 0.26. We have 0.26. Does this z-score make sense? Yes, the z-score is between what? 0 and 1. This means 0.26 or 1/4 of a standard deviation to the right of the mean. Okay? Now, so 0.26, we have 160 minus 158.3. Yeah, we're right. Okay, now, let me see here. Okay, so we have our z-score. I'm going to erase this. So 3 steps. Shade the area, find the z-score. Now what do we have to do? We have to look it up on the z-table. So reminding you, on your z-table, you guys should have a copy in front of you. Remember, always keep your z-table in your textbook. So even if you go home, you guys have it to refer to. So z, we go down to what? We go down to the 0.2 column. Oh no, we go down the left column down to 0.2. Don't get confused. I have many students that made this mistake. They went down to the 2.0 column. We are not going down to the 2.0. I'm sorry, we're not going down the column to 2.0. We're going down the column to what? 0.2. Okay, so there's a difference between 2.0 and 0.2. So don't go down to 2.0. We're going down to what? 0.2. Then right to the 0.06. Go right to the 0.06 column. So go down to 0.2. Go right to the 0.06 column. Look this value up. So let's look it up. Down to 0.2. And right to the 0.06 column. I'll show you guys one more time. Okay, so go down Go down to what? Go down to 0.2, which is right near the top. And then right to the what? 0.06 column. Okay? We are at 0.6026. 0.6026. So again, down to 0.2. Okay, and then right to the 0.06 column is 0.6026. 0.6026. Okay, so what does this represent? Again, the Z table gives us what? Area. The Z table gives us area. Now, what is this value? Is this value less than 1? Remember, our total area is 1. Yes, this value is less than 1. This is an area. Okay, so of these three, what does this answer? This answers the probability of the area, 0.6026. Don't do this. This is wrong, this is wrong, this is wrong. Okay, so don't do this. This is wrong. I'm just emphasizing. 0.6026 is not your answer. Reminding you guys, look again at the top of your Z table. What does the Z table give us? The Z table gives us what? Area to the left. Z table gives us area to the left. Now, Z table gives us area to the left. Now, what's half the area, guys? What's half the area? Okay, 50%, well, that's description. What is half the area? Half the area is 0.5. Half of 1 is 0.5. Question, is 0.6026 greater than 0.5 or less than 0.5? Hopefully you say this is greater than 0.5. Okay, so notice our area that we're trying to find. Is our area greater than 0.5 or smaller than 0.5? It's smaller than. Our area is less than half. So this could not be our answer. Okay, remember, Z table gives us area to the left. So question, what did the Z table give us? The Z table gave us the area to the left. So does this represent this 0.6026? Does it represent the shaded area or does it represent the white space that's not shaded? It represents what? The white space, which is what? Let's label the white space 0.6026. So do you guys understand? The white space, or the area to the left of this line, is 0.6026. And this is not what you're trying to find. You're trying to find area to the right. So think about this for a moment. If the Z table gives you area to the left, and you're trying to find area to the right, okay, what can we do here? Do you see that together, these two areas make up the entire area? I always tell students, look, your total area is 1. So if you want to find area to the right, take your whole area, which is 1, and subtract what? Take the whole area and subtract 0.6026. 1 subtract 0.6026 gives what? It gives 0.3974. 0.3974. So there it is, there it is, there it is. So take the whole area. If you want to find area to the right, take the whole area, which is 1, subtract out the area to the left. So remember, to find area to the right, take the whole area, which is 1, subtract out the area to the left, or the area that the Z table gives you. So 1 subtract 0.6026 gives what? 0.3974. Okay, so our area that we're trying to find is 0.3974. So our answer is not 0.6026. Our answer is what? 0.3974. And what did we guess? What did we guess here? We guessed that our area, or our percentage, would be around 40%. How do we get from probability or area? Reminding you, Z table gives you probability or area. Go back to percentage. We move the decimal 2 places to the right, and we get a percentage of what? 39.74%. Pretty good guess. Okay, 40% is a pretty good guess. Now, again, to get how many, we take our probability, which is 0.3974, and multiply by what? Total numbers. So 0.3974 times 900. 0.3974 times 900. Speed this up. Is 357, approximately 357.7, 357.6. So we get 357.6, and we're going to round what? We can't have a partial man. We're talking about 900 men, so let's round to the nearest. Okay, so 357.6 rounds up, we're going to have about what? About 358 for our total number. Okay, now question, what is half of 900? So if you think of this curve as representing 900 men, what is half of 900? Half of 900 is 450. Notice our area is less than half. So if our area is less than half, it's going to represent less than half of the men. If half of the men is 450, okay, and we're less than half, then we're going to be less than 450. So 358 makes sense. Again, to find how many, we take probability, multiply by what? Take probability, multiply by total number, we get what? 358. Okay, so for now, I want you guys to focus on finding area below and finding area above. Okay, to find area below, just look it up on the z table. To find area above, okay, you have to take the total area, which is 1, and subtract out what the z table gives you, the area to the left. Remember, the z table gives you area to the left. Take the whole area, subtract the area to the left, get the area to the right. Okay, take your area, convert to percentage. Okay, also take your area and multiply by total number to get your how many. All right, that concludes this video, and good luck on your homework, guys. Oh, by the way, homework. If you missed class, homework is number... here, let me just write it on the board. Here. For those of you that missed class, homework is page 776, numbers, and I added 12. It's 12 and 13, but I just made up some problems here. So 12E, I want you guys to find the probability that X is less than 215. Number 12D, find the probability, 12F. Find the probability that X is greater than 140. And number 13, you did the other ones last night. Number 13D, find the probability that X is less than 7.9. And for number 13E, find the probability that X is greater than 8.5. Okay, find the probability that X is greater than 8.5. All right, that concludes. So these 4 problems for homework on page 776. All right.